So hello everyone, welcome back to As for Education. Today we'll be solving the Mathematics 9709 Paper 3 Variant 2 of the February-March 2025 session, and the time allowed for this paper is 1 hour and 50 minutes. The total marks for this paper are 75 marks, and now let's start the paper. I would appreciate if you can subscribe the channel and like the video and share with anyone you think it will benefit. So let's start with the first question. So question number 1 says that solve the equation ln 1 minus e raised to the power minus 2x and plus 3 is equals to 0. Give your final answer to 4 decimal places. So we have to give our answer to 4 decimal places. Now you can observe that in this equation we have a term associated with ln and we also have a constant. So what we will do, first of all, we will separate these two terms. So this will become ln 1 minus e raised to the power minus 2x is equals to, and I will shift the 3 to the other side, so this will become minus 3. Now what I can do is that we know that ln always has the base of e, so I can just convert this to the index form as e raised to the power something. Okay, so we have the e here, so this will become 1 minus e raised to the power minus 2x because we have to make x the subject, so this will become e raised to the power minus 3. The e shifted from here to make the minus 3 the power. So now we will combine the constants together. Constants, I mean that the term that are without the x variable, so this will become 1 minus e raised to the power minus 3, and I will just separate the minus 2x to the other side, so this will become is equals to e raised to the power minus 2x. Now again I will apply ln and I will introduce ln on the both sides so that we can bring the power down as a coefficient. Okay, so this will become ln 1 minus e raised to the power minus 3 is equals to ln e minus 2x. Now ln e is equals to 1, so this will become ln 1 minus e raised to the power minus 3 is equals to, this will become minus 2x because ln will be cancelled, it is equal to 1. So now we will have x is equals to ln 1 minus e raised to the power minus 3 divided by minus 2. Now if you simply put it into the calculator, this will come out to be ln 1 minus e raised to the power minus 3, and then we have to divide by 2. Okay, so divide by minus 2, so this will come out to be 0.0255, and then we have 25534. Now they told us that we have to give our final answer correct to 4 decimal places, and in the case if you do not give it in the 4 decimal places, you can lose a mark. Okay, so x will be equal to 0.0255. so till here we have 4 decimal places. Okay, so this will be your final answer. So a relatively easy question. Let's move on to the second question. So second question is about the differentiation, and it is actually they are asking the equation of the curve is xy square plus ln x plus 2y is equals to 1. Find the gradient at the curve where x is equal to 0. So they have already given us the x value at the point, and now we have to find the gradient. Now we know that the gradient is actually equal to the differentiation of the equation. Okay, so but here we have the implicit differentiation. We have to do the implicit differentiation, because you have a look that we have the ln term as well as we have the x and y square multiplying together with each other, so we have to apply the product rule in this. We have to apply the product rule in this. So now let's just solve it. So First of all, we will be applying the product rule, so it will be equal to u v dash, which is differentiation of the v, plus v u dash, and then we have plus the ln, so differentiation of ln will be 1 over the term in the bracket, it will be x plus 2y, and then multiplied with the x plus 2y differentiation. Okay, let me just write the x a little bit different because you will be confused with the multiplication sign as well. So this is your x, the curly x, and the other one is your multiplication sign. So this will be your differentiation of ln, and then we have 1, so 1 will become 0. Okay, so let's write this 0. First of all, you have to decide that what is the u and what is the v term. So I am taking x as u and I am taking the y square as my v term. So this will become x as it is, and the differentiation of y square, plus then we have the y square as it is, and then we will have differentiation of the x plus 1 over x plus 2y, and then we multiply with the differentiation of x plus 2y. Okay, so let me just first of all write this, and then I will differentiate it in one go. So now this will become x, and now what is the differentiation of 2y? The differentiation of 2y, of the y square will become 2y, and because we are in differentiating the y term, it will be 2y into dy by dx. Okay, so this will become 2y dy by dx. Now plus the y square will be as it is, and the differentiation of x is 1. Now plus the differentiation of ln is 1 over x plus 2y, and the differentiation of actually the x plus 2y will be actually equal to the differentiation of x is 1 and 2y will be 2 because it has only one power, so this will become 2, and as we are differentiating the y, it will become dy by dx. You always have to put the dy by dx when you are differentiating the y. So this will be your equation. Now what we will doing is that we have to first of all multiply this term with the x, and then we will be combining the terms that are being associated with the dy by dx. So now let's just do this. Okay, so this will become 2xy dy by dx. Let me just highlight this so that you can just clearly see this. So this is your dy by dx. Okay, so then we have plus y square, then multiply this whole term, this will become plus 1 over x plus 2y and plus 2 dy by dx, and into this will be into x plus 2y. Okay, so this is your whole equation, and now we have to bring the terms that are being associated with the dy by dx. So this will become 2xy dy by dx, then plus 2 dy by dx, and into this will be into x plus 2y, and then we have to bring the other terms to that side so that we can simply make this the subject. So it will become minus y square minus 1 over x plus 2y. Now let's make this the subject. So let's take the dy by dx the common, dy by dx will be the common, and this will become 2xy plus 2 divided by x plus 2y. Okay, and this will be equal to your minus y square minus 1 over x plus 2y. Now just divide this whole term by minus y square minus 1 over x plus 2y. So you will get your dy by dx as your subject. So this will become minus y square minus 1 over x plus 2y, and this will be whole divided by 2xy plus 2 over x plus 2y. Okay, so this is your whole term. Now what we have to do is that we have two unknown terms, the y and the x, but we do know. So now what we'll be doing is that we know that we have two unknown terms, the y and the x. So we have to find the y because they have already given us that x is equal to 0. So what we can do is that when x is equal to 0, we can simply plug in this value of x into the original equation to get the corresponding value of y. So this will become 0 into y square. This whole term will become 0, and plus ln 0 plus 2y. This will become ln 2y is equals to 1. So this will become ln 2y is equals to 1. Now we know that ln e is equal to 1. So ln e equals to ln 2y. The ln cancel. This will become y is equals to e divided by 2. Okay, so this is your y value. This is your corresponding y value. Okay, so now let's just plug in into the equation. So this will become dy by dx is equals to, and we know that y is equals to e divided by 2. So minus e divided by 2 whole square minus 1 over x plus 2 into e divided by 2. The 2 and 2 will be cancelled. Okay, so now let's divide it by the whole term, which is 2 xy, and remember the x is 0, but first of all I am just plugging in the y value so that we can simplify it. So 2 divided by x plus 2 into e divided by 2. So 2 and 2 will also cancel out here. So this will become dy by dx is equal to minus e square divided by 4 minus, this will become 1 divided by 0 plus e, because the 2 and 2 had cancelled. So minus 1 over e. Okay, and then we have to divide this whole term. This will become 2 into 0 and into e divided by 2. So because we are multiplying with the 0, this will become 0. This whole term will be 0. So 0 plus 2 divided by 0 plus e. This will become 2 divided by e. Okay, so 2 divided by e. Now what we can do is that we can bring the denominator into the numerator and we can just reciprocate it. So this will become minus e square divided by 4 minus 1 over e, and this will be now multiplied with e divided by 2. So now just multiply this and this will become minus e cube divided by 8 minus, the e and e will cancel out. This will become minus 1 over 2. So this will be your gradient. Okay, and this will be your final answer. Okay, so I hope it was an easy question. It was just a little bit lengthy. Now question number 3 says the shaded region on the diagram diagram shows the points representing complex numbers z defined by the two inequalities. Now the shaded region is just erased from my diagram. I don't know why, but this is your shaded region. Okay, this point is the shaded region in the paper. Let me just shade this. Okay, so they are talking about this region. So the shaded region is bounded by a circle and a line parallel to the real axis. Now this is the line they are talking about. This is the line that is parallel to the real axis. The boundaries of the regions are included in the shaded region. So you can see that this shaded region is bounded by this whole circle, as well as this is bounded by this straight horizontal line. So find two inequalities in terms of z, the complex number that defines this shaded region. So first of all, if you look into this shaded region, you can simply identify this, that it is lying below this horizontal line, and this horizontal line is at minus iota, or you can simply write it as -1. Okay, so what we can do is that this is the imaginary part, so this we can simply write this as imaginary part of z is less than, and as well as we have the solid line, so we will write here is equals to. Okay, so it is less than equal to, the -1. Okay, the second inequality that we will have is that you can see that it is bounded inside the circle. Okay, this is your center, this point is your center, and this is at -2 comma iota, or you can just simply write -2 comma 1. So this is your center, and let's check what is the distance of the circumference from the center. So if you check it in any direction, it will be 1, then we will have 2, and then we will have 3. So this is the point. Okay, now what you can see is that we often just discuss it in the general form that z minus z1 is equal to or less than or greater than r. Okay, it can be anything, it can be equal to, greater than, or equal to r, which is the radius. Okay, so this is the z, that is the complex number that is being bounded by this circle. So what we have to do is that we can just simply write it as z, the distance of z from the center. Okay, we are actually, this is the point of reference. Okay, so z minus -2 comma 1, the distance of this from the z, and the modulus of this is actually less than the radius. Okay, because it is inside the circle, it is not outside the circle, it is inside the circle, and also it is lower than the -1, so we write it as less than 3, which is the radius. But because we have the solid line as well, we will write it as equal to. So the first inequality will be that the imaginary part of z is less than equal to -1, and the second will be, let me just erase this and write it again. So the imaginary part of z will be less than equal to -1, and the distance of z from the center -2 comma 1 modulus is less than equal to 3, because it is inside the circle. So this will be your two inequalities. Now B part said find the greatest value of modulus of z for the points in the region. Now whenever they talk about the points in the region, what we have to do is that we have to find the modulus is actually the distance from the origin. Okay, so if for example this is your origin, you have to look for the maximum distance or the maximum modulus from this origin that lie inside this circle. So for example, if I just draw a horizontal line here and I'm just dragging it about this whole point, you can see where the maximum distance just occurs. Okay, so we do not have the maximum distance till here, till here, till here, till here. Then we will have the maximum distance or the greatest value of the modulus at this point. So we have reached the conclusion that this is the point of maximum modulus from the origin. But you will note that this is not exactly 4, this is lying somewhere between this point. Okay, so what we will do, let me just erase these values. So what we will do is that we will find this distance, that what is this distance, by simply making a triangle here. This will be a triangle. Let me just make this triangle. We can simply make this triangle, and we know that the distance of this, let me just draw this, the distance from the center to this base, the distance of the center to this base is 2 units. You can clearly see it. The distance is from iota to minus iota, so it will become 2. So this is the 2 units, and we also know that the point that we have till here is minus 2. So what we will do is that we will find this distance and then we will add up this to minus 2. So let me just make this diagram here first. So it is something like this. Let me just draw this. Okay, so let me arrange it a little bit. So this is how the diagram looks like. Okay, and this is the vertical line that is from the center to the base. So this is minus 2 comma 1, and this is your point of origin, this is your point of origin 0 comma 0, and this is that point which you are finding. Okay, so what we will do is that we will just sorry, this is not 0 comma 0, this is 1 comma 0, minus 1 comma 0, because we are below the graph in the y-axis. Okay, so this will be, let me just write this again, so this will be 0 comma minus 1. Okay, so first of all, how can we find this? We know that this vertical distance is 2 units. We also know that this is the radius of the circle. You can clearly see this is the radius of the circle, so this will be 3 units, this will be 3 units, this will also be 3 units. So what we can do, we can simply apply the Pythagoras theorem on this triangle. We can apply the Pythagoras theorem on this triangle and we can simply find out this distance. Okay, so this will be equal to, the hypotenuse square is equals to 2 square, and this will, let's just suppose this is x. Okay, so plus x square, so x square will be equal to 3 square minus 2 square. This will become 9 minus 4, and this will become 9. 3 square is 9, and 9 minus, let me just check it again, so this will be 2, and then we will have this as 3, so this will become 3 square is 9 and 2 square is 4, so this will be 9 minus 4, so x square will be equal to 5 and x will be equal to under root of 5. So this distance is actually under root 5. Now we know that we have minus 2 till here, so we will add up this distance to this, so this point will actually be equal to minus 2 minus 5 comma, and we will have minus 1. Okay, we have minus 1 here. So now what we will do is that we can simply find the distance of the origin to this point. So let me just draw another line here. So for example, this is the point and this is your other point, so this is minus 2 minus under root 5 and minus 1, and this is your 0 comma 0. Now you have to just find distance, apply the distance formula and find the distance. So this is your distance formula. Okay, this is your modulus of z, the greatest or the maximum value of the modulus of z. So this will be x2 minus x1, so it is 0, so we can just simply write minus 2 minus under root 5 square plus we have minus 1 plus 0, so it will become minus 1 squared. So now let's do the working. So this will become minus 2 minus under root 5, and we have to square this value. This will become 9 plus 4 under root 5 and plus 1 and under root this, so this will become 10 plus 4 under root 5, and there will be an under root here as well. So now this will be your greatest value of the modulus for the points in the region. Okay, this is the greatest value. Now fourth question says, by first expressing the equation tan into x minus 60 degree is equals to 2 cot x as a quadratic equation in tan x, solve the equation for x is less than or equal to 180 and it is greater than 0. So it is just first of all we have to prove this, not prove this, we have to just solve this and form a quadratic equation, and then we have to solve it. Okay, so this will become, as we know the identity, tan a minus b or alpha minus beta is equal to tan a minus tan b and divided by 1 plus tan a tan b. Okay, so now let's solve this question. So this will be equal to tan x minus 60, this is the original equation, is equals to 2 cot x, and then we will just open this equation, so this will become tan x minus tan 60 divided by 1 plus tan x tan 60, and this is equal to, we can just write the cot in the form of tan, so cot x is equal to 1 over tan. Be careful here that we do not have to reciprocate 2 as well. Okay, it will be 2 divided by tan x. Now we know that tan 60 is equals to under root 3, so tan 60 is equals to under root 3, so this will become tan x minus under root 3 divided by 1 plus under root 3 tan x is equals to 2 divided by tan x. Okay, so we can just simply multiply the tan x with the upper side and the 2 with the lower side. Okay, so this will become tan x into tan x minus under root 3 is equals to 2 plus 2 under root 3 tan x. Now just multiply this will become tan square x minus tan under root 3 is equals to 2 plus 2 under root 3 tan x. Now just bring the terms to one side, so this will become tan square x, this will become minus tan under root 3, and the other one was 2 under root 3 tan x. So these will essentially add up, and then we have minus 2. This will become tan square x minus 3 under root 3 tan x minus 2. So this is your equation, this is your quadratic equation that you have to obtain. We have expressed this as a quadratic equation. Now just solve it using the quadratic formula, and then we will just find out the angles. Okay, so tan x will be equal to minus b, so this will become minus 3 under root 3 plus minus under root b square, so b square will be minus 3 under root 3 square, and b square minus 4ac, so a is 1 and c is minus 2. Okay, and then we have to divide this whole by 2a, so 2 into 1, so this will become minus 3 under root 3 will be 3 under root 3 because it will become plus, and plus minus, then we have, let's solve this whole under root, so this will become under root minus 3 under root 3, and this whole term will be actually squared, and then we have minus 4 into minus 2. Okay, so this will be equal to under root 35. So this will be equal to under root 35, and this will be divided by 2. So either we can have the value of tan x as 3 under root 3 plus under root 35 divided by 2, or we can have the value of tan x as 3 under root 3 minus under root 35 divided by 2. So now let's check the value of 3 under root 3 minus under root 35 divided by 2. So now if we take the inverse of this value, let me just take the inverse of this. So x will be equal to this will be the basic angle, so this will be alpha. So alpha will be equal to tan inverse, and you have to ignore the sign, so this will become 3 under root 3 minus under root 35 divided by 2. So let's just check what alpha comes out to be. So alpha is tan inverse of, let's check, 3 under root 3 minus under root 35 and divided by 2 comes out to be minus 0.3599, but you have to ignore the sign. So tan inverse, of this will be equal to 19.79. So 19.79, but you have to keep in mind that the sign of this is negative. Okay, let's check for the other one as well. So this will be alpha is equals to 3 under root 3 plus under root 35 divided by 2. Take the inverse of this, this will be equal to 79.79. 79.79. Take as many decimal places as you can. So this is positive. Now we know that the range of over theta was from 180 to 0. Okay, so we have to first of all make a grid. We have to make a small grid. Okay, so let's just make this small grid. So this is over grid, and we know that our range is from 0 to 180 degrees. Okay, so we know this is positive, so all trigonometric ratios are positive in the first quadrant, and only sign is positive in the second quadrant. Okay, so this will only form this angle, so this will be equal to, this angle will be equal to 79.79 degree. So our first value of theta will be 79.79, and because we know that it was negative for the 19.79, so we will have this angle here 19.79. so this will be 180 minus 19.79, as it is negative, so this will be equal to 180 minus 19.79. this will come out to be 160.21 degrees. So this is your answer for this question. So question number 5 says the square roots of minus 4 plus 6 under root 5 iota can be expressed in the Cartesian form as x plus iota y, where x and y are real and exact. So they have given us the clue that it is real and exact. This means that we have to choose the real and exact values from the answer that we'll be finding out by first forming a quadratic equation in x and y. Find the square roots of minus 4 plus 6 under root 5 iota in the exact Cartesian form. So quadratic equation means that it is to the x power of 4. So first of all, what we can do is that the square root, so the square root of minus 4 plus 6 under root 5 iota is equal to x plus iota y. So we can just square both of the sides, and the square root and the square will cancel out. This will become minus 4 plus 6 under root 5 iota is equals to, then we have to apply the identity on this. a square plus 2ab plus b square, so this will become x square plus 2yx and plus I square y square. So you know that iota is equals to minus under root minus 1, so iota square will be equal to minus 1, so this will become minus y square. So minus 4 plus 6 under root 5 iota is equal to x square minus y square plus 2yx, and this has the iota part. This means that this is the real part. Your real part will be equal to this real part, and your constant part, or you can say the actually this is the imaginary, the one I have highlighted in the green, this is your imaginary part, so it will be equal to 2y x iota, and this is the real part minus 4, which should be equal to x square minus y square. Okay, so now what we'll be doing is that simply let's just first of all let me just separate this page into two. So now what we'll be doing is that we will just equate each of them. So minus 4 is equals to, it is equal to x square minus y square, and the other one is that imaginary part 605 iota is equals to 2yx iota. So iota and iota will cancel out, so you can find it in the terms of x and y. This will be equal to, so let's just find it in terms of x. So x will be equal to 6 under root 5 divided by 2y, and now we can just simply substitute it in this equation. So we can substitute it in this equation, so this will be equal to 6 under root 5 divided by 2y square minus y square, should be equal to minus 4 is equals to 6 under root 5 square is equal to 180, and square of 2y is equals to 4y square minus y square. So now if we take the LCM, this will be equal to minus 4 is equals to 180 minus 4y to the power of 4 divided by 4y square, and then what we will do is that we can just simply multiply the denominator with this. So this will be equal to minus 16y square is equals to 180 minus 4y square y to the power of 4, and now let's just rearrange this. This will be equal to 4y to the power of 4 minus 16y square and minus 180. So now what we can do is, let me just have a look at this. So this was our original equation. So now we can just simplify this a little bit by dividing it by 4. So this will be equal to y to the power of 4 minus 4 to the power of y square and minus 45. Okay, so now what we can do is that we can have to just find the common factors. So if we just find the common factor, this will be equal to 9 and 5, I think. So y to the power of 4, and then we can have it as minus 9 y square plus 5y square minus 45 is equals to 0, and this will be equal to y square into y square minus 9. I think it will be 9, but let's just see. Okay, so 9, and then we will have plus 5 into y square minus 9. This will be equal to 0. So one bracket will be y square plus 5, and the other one will be equal to y square minus 9 is equals to 0. This will be equal to y square is equals to under root plus minus under root, and this will be minus 5. So if we just remove the square as well. So then it will be equal to plus minus under root minus 5. Now they told us in the question that it was real and exact values. Remember when I highlighted it? So this means that it cannot be in terms of complex number, or you can say imaginary numbers. This will be not possible. Let's check for the other one. It will be equal to y square is equals to 9. So y will be equal to plus minus 3. Okay, so if y is equals to plus minus 3, now what we can do is that we have to find the x value as well. Okay, so we know that y can be either minus 3 or y can be either plus 3. So this will be equal to, x will be equal to 6 under root 5 divided by 2 into minus 3. So this will give us the x value as, let's just check what is the value. So minus 6 divided by minus 6, this will give us minus under root 5, and the other one will give us x is equals to 6 under root 5. This will be equal to 2 into 3. So this will give us the value of x as under root 5 only. So this means that our answer can only be, it can only be, we have to give it in the form of x plus iota y. So in the first condition, it can only be under root 5 plus 3 iota, or it can be minus under root 5 minus 3 iota. Okay, so this will be your answer. Let's move on to the next question. So it is about differential equations. So let me just pick up the red pen. So the variable x and theta satisfy the equation, differential equation dx divided by d theta is equals to 1 by 5x plus 1 into sine square 2 theta, where x is equals to 5 and theta is equals to 0. Solve the differential equation and obtain an expression for x in terms of theta. So first of all, as we know that we move on the terms according to what we are differentiating. So what we can do is that this can be written as 0.2x plus 1, just to reduce some confusion. Okay, so I can write it as this. So this is written as this. Okay, so now what I can do is that simply move the x terms toward the x and the theta terms toward the theta, so that we can integrate with respect to that. So this will be equal to 1 divided by 0.2x plus 1 and dx, and we will move the d theta toward that side. So, and the sine square theta will remain to that side, because we are just moving the d theta towards that side as well. So now this will be your equation, and now what we have to do is that we have to integrate both of the sides. But before that, we have to simplify over, you can say we have to reduce this to from the square. So we have an identity, that is cos 2 theta is equals to 1 minus 2 sine square theta. Now we want the sine, so we will just make it the subject. So this will be equal to 2 sine square theta is equals to 1 minus cos 2 theta. Now if you have a look at this, whenever we have this theta, let me just pick up another color. So whenever we have this theta, the theta with the cos is double of that. It is a double angle. So now we can just rearrange it according to our sine, which is 2 theta. So this will become 2 sine 2 theta is equals to 1 minus cos 4 of theta. Okay, and now you can just say that sine square theta, sorry, this will be sine square theta, sine square 2 theta will be equal to 1 minus cos 4 theta, and just we have divided the 2, which was the coefficient of sine square 2 theta, and this will become 1 minus cos 4 theta divided by 2. Let me just move it a little bit here. So this is the identity that we are going to be replacing the sine square 2 theta with. So now what we can do is that we first of all we just simplify it. So this will be equal to integration of 1 minus cos 4 of theta divided by 2, and with respect to d theta, and in the other one it is 1 divided by 0.2x plus 1. Now we just have to integrate it, but for the minus 1 we can just simply write it as you can say separately. So this will be equal to integration of half, and then we have minus the integration of half. Let's just write the half here because the half is with the both. You have taken out it as common. This will be equal to half into cos 4 theta, and both with respect to d theta. Okay, so now let's just copy this as it is. Now we know that whenever we have the, you can say that if we just write it in the differentiation form, whenever we have the so what you can do is that you can have the differentiation of this. We can just have the differentiation of this, and we can write it in the form of ln. So this will become, we have to apply the differentiation in we have to make the differentiation in the numerator. So this will become the differentiation of 0.2x will be 0.2, so it will be equal to 1 by 5, and 1 by 5 will become 5 in the numerator. So let's just write it out of the integration sign. So this will be 1 over 0.2x plus 1, so it will be 1, and now the integration of half will be half theta, and minus we have the half into the integration of cos 4 theta. So the integration of cos 4 theta will be sine 4 theta, and then we have to divide by differentiation of the 4 theta, so it will be divided by 4. Okay, so I hope it's clear. So now what we have to do, we have to just remove the sign of the integration, and we will the integration of this 5 divided by 0.2x plus 1 will be ln. This will be 5 ln, and then the denominator, so it will be, you can just simply write it as 0.2x plus 1. And if I write, in the case if I just write it as in the form of you can say actually what I have done here is that I just simply moved out the 0.2, like 0.2 is equals to 1.5, 1 over 5. So if 1 over 5 is in the denominator, so I just move the 5 over here. Okay, so there will only be x here, so let me just only write the x. So we will have 5 ln bracket x plus 1 x plus 5, because we have taken out the LCM. Okay, and then we have to move it out. So it was 5 ln into x plus 5, then is equals to, we will have half theta minus sine 4 of theta divided by 8. Okay, and now what we can do is that we already have it in the form of you can say, we will also have the constant. And now what we can do is that we can just make 5 the power of it. So if we make 5 the power, or what you can do is that first just you can say find out the c. So to find out the c, what we can do is that they have given us the value of x and theta. So the theta is 0 and the x is 5. So let's just do that now. So x is 5, theta is 0. So we will just plug in the values of x. So this will become 5 ln 5 plus 5 is equals to half into 0 minus sine 4 into 0 divided by 8 plus c. So all of these terms will actually become 0. Okay, so if these become 0, so we can have 5 ln 10 and this will be equal to your c. So let me just enclose it in a box. So this is your equal to your c. Now what we have to do is that we have to solve it further. We have already found out the c, so this will become 5. Now we can make the 5 as power, okay, because we have already found out the c. So for simplification we will just make it the power. So is equals to half theta minus sine 4 theta divided by 8 and plus 5 ln 10. Okay, now what we can do is that we know that the ln always have the base of e, so we can just convert this into the index form. So it will be equal to x plus 5 is equals to e raised to the power, and then now what I'm going to be writing is in the power of e. So it is going to be half theta minus sine 4 theta divided by 8 and plus 5 ln 10. So now what I can do is that we have the x plus 5 whole raised to the power of 5. So now what I can do is I can just, you can say, multiply this by the power of 1 by 5. So it will multiply with all of them, and we will obtain x plus 5 because it will cancel out with the power of 5, and then we have e raised to the power 1 over 10 theta minus sine 4 theta over 40, and then we have plus 5 ln 10 over 5. So the 5 and 5 will all cancel out. Now what we can write it as? We can write it as x. Actually we have to obtain a term in terms of x. So it will be x is equals to e raised to the power of 1 over 10 theta minus sine 4 theta divided by 40, and then we will have plus ln 10, and then the plus 5 have moved to that side, so it will become minus 5. Now what we can just simply do in the last step is that we can just you can say make the e into the ln 10 as to, you can say, we do know that whenever two terms of ln are being, you can say, or you can say according to the indices rule, whenever two terms that have the same base, when they are multiplied, their powers are added. So we can apply the same method here, and this means that e raised to the power 1 over 10 theta minus sine 4 theta divided by 4 and into this dot means into e ln 10. So now if I just move the ln before the e, so this ln and e will cancel out and only 10 will be left, and then we have minus 5. So we can have the last, or you can say the final expression in terms of e as 10 e raised to the power 1 over 10 theta minus sine 4 theta divided by 4, and then we have minus 5. Okay, so this is your final answer. This is your final answer. Now let's move on to the next question. So the next question says the diagram shows the curve y is equals to x cube cos 2x for the range the x is less than 1 over 4 pi, it is greater than 0. The curve has a minimum point at m. So the minimum point at m means that they are going to give you the hint that we have to form the differential equation in the form of stationary points where dy by dx is equals to 0. So show that p satisfies the equation. P is equals to half tan inverse of 3 over 2p. So now, and where x is equals to p, they've also given you the one of the condition. Okay, so this means they are going to give you the hint that you are going to be finding out the stationary point, okay, in terms of p. So now if you are going to be differentiating this to become y is equals to x power 3 cos 2x, and now we are going to be differentiating this, so this will become your u, this will become your v. So to apply the product rule for the differentiation of uv, we have to do u into v differentiation, then plus v into u differentiation. Okay, so first of all, let's just write the u as it is. So this will become x power 3, and the differentiation of v will be minus sine 2x into 2, the differentiation of 2x, and plus, then we will write the cos 2x as it is, and it will be into the differentiation of x cube, which will be 2x square. So this is the dy by dx of this, and it will be equal to 0. So now what can happen is that this will become minus 2 sine 2x, and then we also have the x cube here, plus cos, so become 2x square cos 2x, and this will be equal to 2 sine 2x into x cube is equals to 2x square cos 2x. Now what we can do is that they told us that the x is equals to p at the stationary point. Okay, they have given you this condition. So now we will replace the x with p. So this will be equal to 2p cube sine 2p is equals to 2p square cos 2p, and then what we can do is that just cancel out the 2, so 2 and 2 will cancel out. This will become, okay, so just give me a second. Okay, sorry. So I have actually done a mistake. What was the mistake is that you can say the differentiation of x cube will be 3x square. I just mistakenly wrote 2x square. So it will be 3x square. Let me just correct this. So 3x square, and let's also just correct wherever we have done this mistake. So be very vigilant. So 3x square, and this will be 3x square, and this will also be 3p square. Okay, so now what will happen is that we can just arrange this sine over cos. This will be equal to sine 2p divided by cos 2p is equals to 3p square divided by, then we will have 2p cube, And now we can just arrange the sine 2p or cos 2p as tan 2p. So tan 2p is equals to the p cube and the p square will cancel out. This will be equal to 3 over 2p, and then at the last we will have it as tan inverse of 3 over 2p and into half. This will give us the value of p. So now let's move on. So the B part says show by calculation that 0.5 is less than p and p is less than 0.7. So first of all, what we can do is that we know that p is equal to half tan inverse of 3 by 2p. So first of all, we will put the 0.5 and then we have to put the 0.7. So if the sign changes, it means that the root lies within this range. So this will be 0.5 minus the half tan, and please make sure that the calculator is in the radian mode, because in the first part they specified the range in the radian. So this will be half tan inverse of 3 divided by 2 into 0.5 is equals to this will be is equals to minus 0.1245. Now let's check for p is equals to 0.7. 0.7 minus half tan inverse 3 divided by 2 into 0.7. This will be equal to 0.7 minus half into tan inverse and 3 divided by 1.4. This will come out to be 0.1329. So now if you check, the sign is changing from negative to the positive. So we can say that the root lies within the range p is less than 0.7 and less than, less than 0.5. Okay, so this is the answer for this question. Let's move on to the third part. Use the iterative formula based on the equation in part A to calculate p correct to 3 decimal places. Give the result of each iteration to 5 decimal places. So in the iteration, what we do is that first of all, if we have this equation half tan inverse of 3 divided by 2p, so first of all what we have to do is that we have to select a value which is the p1, and the p1 is the average of the two values, like the 0.5 and the 0.7. so this is the average of this value, and then for the p2, for the p3, then we put the answer from p1, and for the p3 then we put the answer from the p2. So there is a form of iteration that is going on. Okay, so first of all, for the p1 the value will be the average of these two, which will be 0.6. so let's do the working now. So this will be the p1 half tan inverse 3 divided by 2 into 0.6. This will be 0.5 into tan inverse of 3 divided by 1.2. This will come out to be 0.595, and we have to give to 5 decimal places. So 59514, or you can just round it out to 15. Okay, so this is the value for p1. Then for the p2 you have to choose this value. So half tan inverse of 3 divided by 2 into 0.59515, and this will give you the value of, let me just give me a second. So this will be 0.5 tan inverse of 3 divided by 2 into 0.59515. This will give you the answer of 0.59654. Okay, so now let's check for the P3. We have to check until it just becomes equal. Okay, so then this will be 0.5 tan inverse 3 divided by 2 into 0.59654. I will just directly write this, so this will be 0.59613. okay, so now for the P4 it will be 0.5 tan inverse 3 divided by 2 into 0.59613. It will be equal to 0.596255. So when these three decimal places just becomes equal, then you have to stop. Okay, so this will be the answer for this question. Let's move on to question number 8. So question number 8 is from the vectors. It is from the vectors. So two lines have the equation r is equals to, they've given you the point and the direction vector, and then for the other equation, for the other line equation, and then we have to show that the lines are skew. So first of all, what we have to do is that we have to find the equation for the x, y and z for each of them. So the x for the first one will be -1 plus 2 lambda. For the y, which will be 3 plus 3 lambda, and for the z it will be -4 minus lambda, and for the other one it will be x is equals to 2 minus mu, y is equals to -3 minus 2 mu, and z will be equal to -1 plus mu. So now what we have to do is we have to just equate x with x, y with y, and z with z. Okay, so this is what we have to do right now. Okay, so first of all, the x for the first one is -1 plus 2 lambda is equals to 2 minus mu. Let's make the lambda a subject, so lambda will be equal to 2 minus mu and plus 1 divided by 2. So this will be equal to lambda is equals to 3 minus mu divided by 2. Okay, this is the first you can say expression for lambda. Now let's find the other equation for lambda for by equating the y. So 3 plus 3 lambda is equals to -3 minus 2 mu. This will be equal to 3 lambda is equals to -3 minus 2 mu and -3. Then this will be equal to 3 lambda is equals to -6 minus 2 mu, and lambda will be equal to -2 minus, sorry, not -2, it will be, let me just adjust this, will be -6 minus 2 mu divided by 3. Okay, this is the other expression for lambda. Now what we can do is that we have to also find for the z. So z will be -4 minus lambda is equals to -1 plus mu. So let's find the mu this time. So this will be -4 minus lambda plus 1 is equals to mu. This will be -3 minus lambda, and let's just move it to the right. So this will be equal to mu. Okay, so this is your expression for mu. Now what we have to do is that we have to find the value of mu and the lambda, and then we'll be checking with this equation. Okay, so let's equate both of the lambdas. So this will be 3 minus mu divided by 2 is equals to minus 6 minus 2 mu divided by 3. So this will be 9 minus 3 mu is equals to minus 12 minus 4 mu. So this will be equal to mu is equals to minus 12 minus 9. So mu will be equal to minus 21. Okay, this is the value for mu. Now let's find for the lambda. So lambda will be 3 minus minus 21, so it will be 3 plus 21. 3 plus 21 is 24. 24 divided by 2 is 12. So lambda value is 12. Your value for lambda is 12. Now what we have to do is that we just have to plug in these both of the values in this equation. So whether we prove that if it is equating to each other, then it will be intersecting line, otherwise it will be askew. So minus 21 is equals to minus 3 and minus 12. So this will be equal to minus 21 is equals to minus 15. So they both are not equal. So we can just write hence they are not equal. So both lines are skew. Okay, so this will be the answer for this question. Let's move on to the B part. The B part says that find the obtuse angle between the direction of the two lines. So what we have to do is that we have to find the obtuse angle. It means that greater than 90. So obtuse angle we have to find it using the direction vector. So we will write the direction vector 1, vector 1, and this will be your direction vector 2. Okay, so this is direction vector 1 and this is your direction vector 2. Let me just move it a little bit to the left. Okay, so now let's check what is the direction vector for first. It is 2, 3 and minus 1. So 2, 3 and minus 1. This will be 2, 3 and minus 1. Okay, and for the other one it will be minus 1 minus 2 1. It was minus 1 minus 2 1. Okay, so minus 1 minus 2 and 1. So now what we have to do is that we know that the angle is just found out by the direction vector 1 into direction vector 2 is equals to the magnitude of vector 1 into the magnitude of the vector 2 and then cos of theta. So let's check that what is this is the vector 1. Okay, 2, 3 minus 1, and let's first multiply this. So this will be the resultant of this will be, and you multiply this will be minus 2, this will be minus 6, and this will be minus 1. Okay, so let's just erase this and let's write this instead of this. So this will be minus 2 plus minus 6 and minus 1. So this will be your multiplication of these two vectors, and then we will find the magnitude. So the magnitude will be 2 square plus 3 square, and it will be minus 1 will be plus minus 1 square, and then into minus 1 square plus minus 2 square and plus 1 square. So this will be minus 9 is equals to, this will be equal to let's just check. So under root 4 plus 9 and plus 1, so under root 14. This will be under root 14, and this will be multiplied with the 2 plus 1 is 3, 3 plus 1 is 4, so it will be 1 plus 2 plus 1 plus 4 plus 1, so it will be let's check this. So under root minus 1 square plus minus 2 whole square plus 1 square. This will be under root 6. Okay, so under root 6, and then we have cos of theta. Now if you just find out the theta, it will be cos inverse. Actually, this will not be your theta, this will be just your basic angle. Okay, so let me just write it as alpha. So this will be minus 9 divided by this will be 9 divided by under root 14 and under root 6. This will be equal to under root 14 into under root 6, and then just let's find the cos inverse of this. So this will be, just give me a second, so 9 divided by under root 14 divided by under root 6, and then cos of inverse of this. So this is going to be in the degrees. Let me change the, so the cos inverse of it will be about, it is coming out to be 10.89 degrees. Okay, so now what we will do is that we know that this will be negative. Actually this is negative, but in the basic angle we ignore this. So first of all, let's make this grid, and now we know when this is a negative, then we have the obtuse angle in the second quadrant. So because the cos is negative in the second quadrant, so it will be the basic angle will be about 10.89, and the obtuse angle will be 180. The obtuse angle will be 180 minus 10.89. This will come out to be 180 minus 10.89. It is 169.1. Okay, so 169.1 to a decimal place. So this will be your answer for this question. Let's move on. So question number 9 says the polynomial 6x cubed plus ax squared plus bx plus 9 is denoted by p of x, where a and b are constant. It is given that the x minus 3 is a factor. So if it's a factor, this means that if we just plug in 3 into the whole equation, it will give us 0, and when the first derivative is divided by the x minus 3, then the remainder is 72. This means if we divide by this factor, then it will give us the remainder. So this one is following the remainder theorem, and the other one is following the factor theorem. So find the values of a and b. So first of all, what we can do is, according to the factor theorem, according to the factor theorem, we'll just find the first one first. So this will be, if x minus 3, it is the factor of this, so this means x is equals to 3, and if p is equals to 3 is 6 into 3 cube plus a into 3 square plus b into 3 plus 9. So this will be equal to 0. So let's just work this out. So 6 into 27 is 162. This is 162 plus 9a plus 3b plus 9 is equals to 0. So 9a plus 3b will be equal to, let's just find the first equation. So 162 minus plus 9 is 171. This will be equal to minus 171. And can we take out any common? Yes, we can. So just divide this by 3. This will be equal to 3a plus b is equals to minus 57. Okay, so this will be your first equation. Okay, let me just correct this. This is going to be our first equation. Now they have told us that the first derivative of p of x, so first derivative of the p of x, this is 6x cube plus ax square and plus bx plus 9. So if we just, this is the p of x, so if we found the derivative of this, it will be 18x square plus 2a x, and then it will be plus b, and the 9 will be 0 because it is a constant. So it means that if we just plug in 3 here, it will be equal to 72. So 8 into 18 into 3 square plus 2a into 3 plus b will be equal to 72. So 9 into 18 is 162. 162 plus 6a plus b is equal to 72. So 6a plus b is equal to 72 minus 162 minus 72 is 90. It will be equal to minus 90. So minus 90. Okay, so now what we can do is that just uh, we can just use the simultaneous equations, or we can just subtract them from each other. So I this will be 6a plus b is equals to minus 90, and then 2 into 3a, so minus 2 into 3a, so it will be minus 6a minus 2b is equals to 114. So this will be equal to minus b is equals to 114, and this will be equal to 24. So b will be equal to 24. So if b is equal to 24, so 3a minus 57 plus 24 and divided by 3, so it will be minus 11. Okay, so it will be minus 11. A will be minus 11. So these are the values for a and b. Let me just move it a little bit to the left so you can clearly see this. These are the values for a and b. So if you are going to be writing the final equation, it is going to be 6x cube plus, sorry, not plus, it will be minus 11 x square plus 24. It is not plus 24, it is going to be minus 24. Minus 24, here it is minus 24, 24x and plus 9. So this is actually equal to your p of x. Okay, so the second part says when a and b have the values found in part a, factorize p of x completely. So we have 6x cube minus 11x square, it is 11x square minus 24x plus 9, so plus 9. Okay, so now it is plus 9. So we do know that if we have the factor of x minus 3, then something that actually have the power of it is quadratic equation, then that is multiplied with this factor to make it cubic. So it will be ax cube ax square plus bx plus c. Okay, so now if we just multiply this will be equal to ax cube plus bx square plus cx, and then minus 3ax square minus 3bx and minus 3c. So now let's just arrange this. So it will be ax cube, then we have bx square minus 3ax square, and then it will be the constants will be then we have this cx plus cx minus 3bx, and then constant will be minus 3c. Okay, so what we have to do is just compare the power with the powers. So it will be 6x cube will be equal to ax cube. So it means that a is actually equal to 6. So a is equal to 6. Now if we don't know the a, then for the square it will be minus 11x square. This will be equal to how much? This will be equal to b minus 3a. So minus 11 is equals to b will be, we do not know what is b is, and 3 into 6 is minus 18. So minus 18 shifted to that side will be plus 18. This will be equal to b is equals to 7. Then for the c we have the minus 24 is equals to cx minus 3b. Okay, so let's just remove this x. Okay, this has nothing to do here. So c minus 3b, so it will be minus 24 is equals to c minus 3 into 7, so 21 minus 21. Here it will become plus 21, so it will be c will be equal to minus 3. So now what we have to do is that all of things are done. So minus 3c will be 3 into minus 3 will be equal to plus 9. Okay, so can we write the full equation? So yes, we can, and this will be equal to, let me just write this equation. So it will be 6x square, the factorized equation. Okay, the which had the power of 2. So 6x square plus 7x and minus 3. So this is your equation, which is being multiplied with this factor x minus 3 to become the cubic equation. So now we can first factorize this furthermore. So this will be equal to 6x square plus 7x minus 3, and it will be 6 into 3 is 18. So what 18 is equal to? 9 into 2 is 18. So 6x square plus 9x minus 2x minus 3 is equals to 0. This will be equal to 3x into 2x plus 3 and minus 1 into 2x plus 3 is equal to 0. So x will be equal to 1 over 3, or x will be equal to minus 3 by 2. Okay, these are the additional factors in addition to the x is equals to 3. Okay, so we have completely factorized this. So if we write it in the completely factorized form, it will be x minus 3 into 2x plus 3, and then we have 3x minus 1. Okay, now the other part says hence solve the inequality p of x is less than 0. So for this you have to just simply make a grid like this. Let's just make this a grid. Okay, so if we have this grid, now what we can do is that we do know that we have the 0 at the origin, then it is minus 1, then let's just put minus 2, minus 3, okay, and 1, 2 and 3. Actually this is the question for the range. Okay, so we have to do it like this. So if one of the root is like 3, so this means one of the root is here, it is cutting this x-axis at this point. Then we have the other root at minus 3 by 2, this means minus 1.5, which will be here, and the other one is 1 by 3, so 1.1 by 3 is 0.33. It will be something about here. This means it can be something about this. Okay, it can be something about this, something equation, a cubic equation like this. So what can we say is that when it is less than 0, so it is less than 0 when the x is greater than 1 by 3 and the x is less than 3. So we can just solve this inequality like this. So x is less than 3 and x is greater than 1 by 3. Okay, so this is how we do these type of questions of solving inequality. Let's move on. So the question number 10 says, let f of x is equals to minus 7x squared plus 2x minus 6 by 1 plus x into 4 plus x squared, x plus f of x in the partial fractions. So the power of the numerator is, the maximum power is square, so, and the maximum power of the denominator will be, if we just multiply it, so it will be cube. So this means that the power of the numerator, this means the power of the numerator is less than the power of denominator. So this is the perfect you can say condition for the you can say the rational fraction, proper fraction. Okay, so now we can convert this into the partial fractions. So first of all, what we will do is that minus 7x squared plus 2x minus 6 divided by 1 plus x into 4 plus x squared. So this will be equal to, as one of the factor is linear, this is the linear factor, so this means that the numerator will have one less power than the x, so it will be a constant, so it will be a. Okay, it will only be a constant. Plus then we have a non-linear denominator, it is x squared. This means that the numerator will be having a power less than that, so it will be bx plus a constant which will be c. Okay, so now what we can do is that multiply this whole denominator, we have to multiply this, okay, and with the numerators, so it will become 7x squared minus 7x squared plus 2x minus 6, because if the it is multiplied with that, the denominator will cancel out, and then we have a, and a will be only left with 4 plus x squared, as it has the 1 plus x in the denominator, it will cancel out with that. Okay, so plus bx plus c into the 1 plus x, because the 4 plus x square will be cancelled with the denominator 4 plus x square. Okay, so now what we have to do is that simply just you can say put the x as, you can say x as minus 1, so this will become x is equals to minus 1. Now we can just simply get rid of the b, because 1 minus 1 is 0, and this whole term will be actually equal to 0. Okay, this whole term will become 0, this whole term will be 0. Now we just simply write minus 7 into minus 1 square plus 2 minus 1 minus 6 is equals to a into 4, and minus 1 square is plus 1, so this will become minus 7 minus 2 minus 6 is equals to 5a, so this will be equal to minus 9 minus 6, so minus 6 will be minus 15 is equals to 5a, and a will be equal to minus 3. Okay, so now we know that the x is directly multiplied with the b, so we can just put x as 0, so we will get rid of the b, Okay, so if we put x is equals to 0, we will get rid of the b. So it will become this whole 7x square will become 0. The 2x will also become 0. We will only be left with the minus 6. So it will be minus 6 is equals to a into 4 plus 0 square, and then we will be plus only c will be left, c into 1 plus 0, c into 1 plus 0. Okay, so minus 6 is equals to minus 3 into 4 plus c, and then we will have minus 6 plus 12 is equals to c. C will be equal to 6. Okay, now what we can do is that just simply just put x as 1, because we already know the value of c and a, so we'll just put x as 1, and just then we can solve it to get over b as well. So the equation is minus 7x square, and then we have plus 2x minus 6 is equals to a into 4 plus x square, a into 4 plus x square, and then we have plus bx plus c is equals to 1 plus x. Okay, so if it is 1, so it will become minus 7 plus 2 minus 6 is equals to a into 4 plus 1 is 5, so a into 5 plus b plus c into 1. Okay, this will become minus 7 minus 2 plus 2 is minus 5, minus 5 minus 6 is minus 11, minus 11 is equals to 5a, 5a is equals to minus 3, and plus b, and c is plus 6, so this will become minus 11 plus 15 minus 6 is equals to b. So this will be equal to minus 17 and plus 15, so this will be equal to minus 2, so b will be equal to minus 2. So I think it will be equal to minus 2, and let me just check it. So I think we have done some kind of mistake. Let's just recalculate. So minus 7 plus 2 is minus 5, minus 5 minus 6 is minus 11, not minus 11, sorry. So this will be not minus 11, minus 6 minus 7 is minus 13, and then we have minus 13 minus 6 is minus 19, and then b will be equal to minus 4. Okay, so this will be your b. Now if we just simply write this whole equation, so this will be as a partial fraction, this will be a was minus 3 divided by 1 plus x, then we have plus 1, b was 4x plus 6, and then divided by 4 plus x square. Okay, so this is whole partial fraction. Now the next part says his find the exact value of integration of with the limits 2 and 0 for the function with respect to dx. Give your answer in the form a pi minus ln b, where a and b are constants. So we know that this f of x in the form of partial fraction is minus 3 over it was minus 3 over 1 plus x, 1 plus x, and then we have plus. Now I'm going to be writing that 4x plus c plus 6 I'm going to be writing that separately because it will help us just integrate it more easily. So 4x divided by 1 plus 4 plus x square, so it will be 4 plus x square, and then plus 6 over 4 plus x square. Let's check if we have just noted down correctly. Yes, we have. So now what we have to do is that we have to integrate each of them. Okay, we have to integrate each of them. So this will be, let me just rewrite this in the proper way. So this will be integration of minus 3 over 1 plus x, and then we have plus integration of 4x divided by 4 plus x square, then plus integration of 6 over 4 plus x square. Now what we have to do is that if you just realize that this is in the form of that we can integrate it to the ln, but first of all the differentiation of this denominator should be in the numerator. So what I can do is that I can just move the minus 3 out of the integration sign, and I can just integrate it as sign. So this will be minus 3 integration of 1 over 1 plus x. Now if you look, the differentiation of the denominator is 1, so it is already present in the numerator, so I can just now integrate as minus 3 ln 1 plus x. Okay, so now let's look into the other ones as well. So now the second one is also in that form, but first of all what we have to do is that the differentiation of 4 plus x square will be 2x, so there should only be 2x in the numerator. So what I can do is that I can move 2 out of the integral sign. This will be 2 into 2x divided by 4 plus x square, and this will become 2 ln 4 plus x square. Okay, and then we have the integration of this last one, which looks to be in the form that we can integrate it to the tan inverse. But first of all, we know that whenever we have a square thing in the denominator, it should be 1 plus something of square of x. Okay, so we should have a 1 first. So for that I will first of all divide this whole by 4. So this will be plus 6 divided by 4. It will be 1 by 4 actually, so let's just divide by 4. Should be 1 plus x square divided by 4. So if this is x square divided by 4, so to make this whole a square, what I will do is I can just write it as, let me just write it as x plus x divided by 2 whole square. So this will become x square over 4. Okay, so I hope you understand this. Now what we can do is that what we have to do is that we should have the differentiation of this as well outside this. Okay, so what we need to do is that we can just write the differentiation of this in the numerator. This will be 0.5, or you can just write it as 1 by 2, and for this we have to also balance the equation because we cannot introduce anything to the equation out of nothing. Okay, so we also have to just balance this equation by writing 0.5 in the denominator, so it will be 0.5 here as well. Okay, so I hope you understand. So this will become plus 3 tan inverse of x divided by 2 whole square. Now we have this whole term. Now they have given us the range, I think. Yes, they had. Let me just check. Okay, let me just check. So have they given us anything? Okay, yes, they have given us the limits. They have given us the limits. So the limits were from 0 to 2. so all of them has the x term associated with them. So if I just plug in the 0, all of them will become 0, but not the ln ones. Okay, so we will just plug in that. So first of all, let's plug in the 2. This will become minus 3 ln 1 plus 2 is 3. This will become 3 plus 2 ln, and 4 plus x square is 8. Then we have plus 3 tan inverse of 2 divided by 2 whole square, and then we have to subtract, and then we have to put the 0. Okay, so then we have minus 3 ln 1 plus 0 is 1. This will become plus 2 ln, so 2 ln, and then we have 4 plus 0 is 4, and then it will be tan inverse of 3 tan inverse of 0 divided by 2, so it will still be 0. So 3 tan inverse of 0 is 0. Okay, so it will be 0. So now if you just calculate this will be equal to minus 27. Okay, so minus 3 ln 3 will be minus 27. It should be minus 27, because if you make the minus 3 the power, okay, so if you make this the power, this will be something about, let me just solve it like this. Okay, so it will be minus 3 ln 3, and then we have plus this will be ln 8 power 2, so 64 this will be, and then we will have tan inverse of 1. So tan inverse of 1 is 45 into 3, so 45 into 3, it is 135, so plus 135, and then actually you can write this in the radians. Okay, so let me just write this in the radians. So tan inverse of 1 is 1 by 4. This will be equal to 3 by 4 pi, and then minus it will become plus, and 3 ln 1 is 0. It will be 0 as well, so 0. Then we have minus 2 ln 4. So 2 ln 4 is, let's just write it as 2 ln 4, and then this is the only thing left. Okay, so now let's just solve this. This will become ln of 27 plus ln of 64 plus 3 by 4 pi minus 2, or you can say this ln 16. Okay, so first of all, let's multiply this. This will become 27 into 64 is 1728. Okay, so 1728 ln of 1728, and minus ln 16 means that it is going to be divided. So, and plus 3 by 4 pi. So 28 divided by 16 is 108. So ln 108 plus 3 by 4 of pi. So this is going to be your answer. Okay, now just let's move on to question number 11, the last question. So find the exact value of the integral of x square cos 1 over 3x dx, and with the limits to pi to 0. So first of all, these two are being multiplied. So first of all, this is going to be integrated using the product rule. So this is going to be integrated using the product rule. Okay, and if you do not know what product rule is, it is is going to be your x square, because you have to select the u, the term which is being reduced to 0 after several differentiations, and the v is going to be your cos 1 by 3x. Okay, so we have selected these. Now let me write the product rule. So the product rule is, it is u difference the integration of v dx minus the integration, and first the differentiation of u, and then multiplied with the integration of the v dx again, and then you have to integrate this whole term. Okay, you have to integrate this whole term. So we are going to be first identifying the integration and differentiation of the terms that we are going to be needing. So first of all, the integration of v dx, which is v is cos 1 by 3x, so cos 1 by 3x, so its integration is going to be sine 3 sine actually, because we have to multiply by the differentiation of the x. Okay, so it is going to be inverse. Okay, because we are going to be moving it out, so to balance that equation we are also going to be multiplying with that. So sine 1 by 3x, this is going to be the integration of this, and then for the differentiation of du by dx, it is going to be x square is going to be 2x. Now we can just simply plug in all of these values. So first of all, u is going to be as it is, x square, then the integration of the v dx will be sine 3 sine 1 by 3x. Okay, this is your whole term, then minus the integration, and first we have the bracket. Okay, so it is going to be 2x multiplied with your integration of this cos 1 by 3x will be 3 sine 1 by 3x, and then with respect to dx you are going to be integrating this whole term. So give me a second. So this is going to be 3 x square sine 1 by 3x, but now if you look that these two terms are actually being multiplied as well, so we are going to be first multiplying this is going to become sine x 6x, sorry, and then sine 1 by 3 of x. Okay, so now we cannot integrate this term, we cannot integrate this term like this. So once again we are going to be applying the product rule. Okay, so first of all let me highlight so that you can understand on which term we are going to be applying the product rule again. So we are going to be applying the product rule on this again. Okay, so in order to integrate this, so now let me just pick up another color so that we can apply the product rule on this. So the product rule is u into v dx, and then we have minus the bracket, the integration of du by dx, so du by dx, and into the integration of v dx and with respect to dx. Okay, so first of all let's just say what over u is. So u is going to be your 6x, and your v is going to be sine 1 by 3. So first of all the integration of v will be, it is sine 1 by 3x, so it is going to be minus 3 cos 1 by 3x, and the differentiation of the u will be 6. Okay, so first of all u as it is 6x, then into minus 3 cos 1 by 3x, then this is the whole term minus, we have to integrate the you can say the du by dx, so it is going to be 6, and then into the differentiation of that, so it is going the integration of the v, it is going to be minus 3 cos 1 by 3x. So this is going to become 18x minus 18x cos 1 by 3x. Then let's just integrate this whole term. Now if we are going to be integrating this whole term now, so what we are going to be doing is that what we can do is that, first of all, let me just give me a second. So this is going to become integration of 18 minus 18 cos 1 by 3x dx. So now if we are going to be integrating minus 18 cos 1 by 3x with respect to dx, so it is going to become, first of all, let's just copy this as it is. So this is going to become the integration of cos is sine, so it is going to become 3 into 18 and then sine of 1 by 3x. Okay, so now we have integrated this will become minus 18 cos 1 by 3x, and then it is going to be minus, so minus is going to be plus, and 54 sine 1 by 3x. And if you remember, we already had a term which we left behind. It was 3x square sine 1 by 3x. I just left so that you are not confused with that. So 3x square sine 1 by 3x. So this was 3x square sine 1 by 3x. Now just plug in the you can say the limits. So the limits are going to be from pi to 0. Okay, so if you just plug in the limits, it's going to become 3 pi square sine 1 by 3 pi minus 18 cos 1 by 3 pi plus 54 sine 1 by 3 pi. Now I'm not going to be plugging in the 0 because all of them has the x and all of them will become 0. Okay, so you can just simply write it as minus 0. Okay, so this will, I'll just calculate this. So this will be equal to sine 1 by 3 pi is it is going to become 3 by square and under root 3 by 2 minus cos 1 by 3 pi is 1 by 2. So this will become 18 into 1 by 2. So then we have plus 54 into under root 3 divided by 2. Okay, so now if you just simplify this further, this is going to become this is going to become 3 under root 3 divided by 2 pi square minus 9 plus 27 under root 3. Other one, it is going to become 27. So this is going to be your answer. Okay, so this is going to be your answer. So your answer is going to be 3 under root 3 divided by 2 pi square minus 9 plus 27 under root 3. So we have attempted the whole paper. Hope you understand. If there are any queries, you can ask me in the comments down below, and like, share and subscribe the video. Share with anyone you can think it will benefit, and I'll be meeting you in another video. Till then, take care and goodbye.